And okay, welcome to class, you guys. So we're wrapping up unit 1. Okay, we're wrapping up unit 1, and you have your first real chemistry quiz tomorrow. Like the first test was how to write like a scientist. No actual chemistry content. Now you know what an atom is. Honors. Now you know what an isotope is and how to calculate the average atomic mass from your isotope abundance, right? You also know how to write numbers, which is a generic good skill in science and math, okay, and STEM. So we're going to go through a couple of the warm-up questions together. I'm going to highlight some of the honor stuff, so prep, sit through it. But eventually, by the way, FYI prep, everything that honors learns today, you're going to learn in about 2 months because it relates to a future unit. It's just that honors is going to get a first dip in it because they're going to peer teach you when that time comes, okay? Honors is like, what? Prep, it would not be a bad idea to listen the entire time as well, because then you'll get it once washed over your brain. And when it comes again, it'll be a little bit more familiar. Yes. It's not graded, so I don't know. The district made it. I just said, why not? But it's not graded. You know, this might get me in trouble as I'm recording right now. Sometimes I don't always agree with how the quizzes are made across the district with some other colleagues of mine, but that's okay because they don't fully agree with me. So, you know, okay. So let's talk about this. For those of you that were gone, okay, remember, anytime that you're absent, like Marie did, she did a really great job. She looks at the video. But there are some things that we just do in class, right? Such as the activity that we did yesterday with the bingo chips to visualize an atom that you will miss if you're not in class. So just feel free to always schedule a time with me. I can go over topics with you. I have a free 4th in spring 2023. I have a free 4th. So come see me. And let's go through our do now. So the first question I asked you was to determine. Okay. For our warm up, we said determine the following for each isotope, or another way generally of putting it is atom. Okay, an isotope is an atom. An atom usually is also an isotope because usually an atom is one version. But oftentimes we talk about the generic atom, right? So don't forget, an isotope is a subset of atoms. It's an atom of the same element type, but with a different mass, a different neutron count, right? And everyone does need to know that. Like everyone needs to know what an isotope is. Only honors needs to know how to calculate from isotopes the average atomic mass, okay? And a couple notation things. So what we have here is I want you to find the proton count, the neutron count, and the electron count for the following. The first one is gallium. Gallium 65. That's the first one. And right here, this is called isotope name notation. Isotope name notation. It's because I write the element, symbol X, or element name, and the mass number. Okay, that's how we do it. So I have gallium 65. I didn't write that it has a charge, so you're just going to assume it's neutral. Gallium on the periodic table is Ga. Anytime we have a capital letter, that symbolizes to us a new element. If you write Ga for gallium, you are wrong. You are telling me it's some compound G bonded with some compound A, neither of which exist on the periodic table. So for those of you that do the cutesy write in all caps, that's stopping. Don't do that. Because you just told me a totally different element that doesn't even exist. Now, capital Ga does exist. That's gallium. Capital G, capital A is a compound that does not exist because those individual elements of G and A do not exist. Okay. So I'm writing little reminders to myself. Okay. So I want you to find gallium 65. So I know that this is my mass number. Okay. My mass number. And that's going to be equal to my number of protons plus my number of neutrons, because one proton is 1 AMU and one neutron is 1 AMU. And then, of course, I assume that you'll figure out the proton count, which is the atomic number, because you should have a periodic table. And that periodic table tells you the number of protons, your atomic number. And then since of course this is neutral, I'm trying to color code as best as I can because I haven't told you otherwise that this is a neutral. Okay, that means the protons must equal the number of electrons. So then what do we get for our number of neutrons, protons, and electrons? So our proton count is equal, okay, to what is gallium's atomic number, proton number? 31. Yeah, you can just shout it out when I'm ready to write it. And then for neutron, what did I do that in green? For neutron count, what do we have? 34, because 65 minus 31 equals 34. Okay, so how about electron counts? What do we got? 31, because we're neutral. We're neutral, right? So hopefully that was a really, really nice in-depth overview. Quickly, just for honors, as you're thinking about this and as people are writing this down, all right, we have actually a special almost version of the periodic table for isotope. We have another called nuclide notation or nuclide representation, isotope representation in a format similar to the periodic table, where we have the element, but instead of putting the atomic number on top like the periodic table does, we put the atomic number on bottom. Because remember, with an isotope, the most important information isn't the atomic number anymore. It's not the identity anymore. Now it's the mass number. Yes. Mew. Yeah. So gallium would be 31. Atomic number Z, right? Z is atomic number. Z is proton number. And then what we put on top is the actual important part for us is the mass number, whole number. That's A, right? Mass number A. Okay. This is the nuclide representation or the isotope version of a periodic table box. If your number, ladies, if your number is bigger, okay, than your other number, you are definitely talking about some version of mass. You would never ever say, it would never make sense to you, if you're thinking straight, that 65 could be the proton number and 31 could be the mass. Like that would make me think that you're talking about antimatter. Okay, you are not. We are never. So make sure that makes sense. Okay, so let's move quicker now through the other ones. Now let's just bust through the other examples. So this was A. Let's do B. So we got my isotope name notation, bromine. Okay, 81. And this time I tell you, this one is going to carry a charge of 1 minus. I'm telling you that. So how many protons do I have? 35. How many neutrons do I have? 46. How many electrons do I have? 36. Excellent. Okay, because it is one more electron than what would be neutral. Okay, C, I have rubidium. Okay, and it is 94. And I tell you, this one, this particular isotopal atom carries a charge of 1 plus. So what are my, don't do it too fast. What are my proton numbers? 37. 37. You good? Yeah. 37. How about neutron number? 57. 57. Woo, ripe old age. And electron count? 36. I have 1 less, okay, electron. 1 less. And I'm going to remove that plus sign up there so you don't get confused. 1 less electron than my neutral. Feeling pretty good, hopefully. Feeling pretty good. Okay, so then that's what I have now. Honors. As the rest of you guys kind of write this down. Let me just do a quick subcategory for honors. When you do your isotope calculations, you also need to keep track of sig figs. Sig figs. So if I tell you I have a mass of 81 and it's 30.12%, and I have a mass of 84 and it's the rest of it, 69.82%. Okay. And you do your math where you multiply, right? You do 81 times, turn the percentage into a decimal, plus 84 times percentage into a decimal. This is for honors only. Okay. Okay, this is the honor section. And you sum it all up. Okay. Because your final mathematical performance was addition, your final answer would be, I don't know if this is the right answer, 82.41. It would be to the second decimal because your percentage was originally to the second decimal of precision. Okay, so that's why we get, and this is like question mark, I didn't do it with a calculator. Okay, that's why we get almost all of our average atomic masses to the second decimal. Okay. Please do not divide again like an average. Your percentage already accounts for out of the whole. So do not double divide and be like divided by 2. Okay. This is not raw data. This is, I already gave you out of 100%, out of a whole count. Here's this that's present. Here's its contribution. Just do the math. Yes.
Nitty gritty, 3 point, it's 83.05. Correct. Like
83.05 is the actual math. Thank you. 83.05. And now I assume that whatever was after this number, when you rounded it, was less than 5.
less than 5.
Well, because if you have 83.05, whatever the number was,
I already rounded.
I know what I'm saying is I'm assuming the way that because of how you rounded it, whatever number was after that was a number less than 5 to round so that you,
No,
yes.
rounding up.
Well, what was the full number then?
Full number is 83.046.
Okay. Good. Okay, just I'm gonna, good. 83.066. So that's why you rounded up to the 5. Excellent. Little note on rounding to sig figs. Okay. So tomorrow, your quiz is gonna be on these things. Everybody, I'm gonna list off everybody first. Scientific notation. Okay. Unit conversions. If you are not tracking your units, you are wrong. You are just straight up wrong. Because again, if I just yell out a number 7 and you don't have a meaning behind it, that's a problem. All right. Next thing you're going to be quizzed on. We already did the CER. We already assume you're going to need a lot of practice writing. We assume you can do that. We'll work on you guys writing less. Just okay, save some trees. Okay. And then we got into atoms. Everyone needs to know the structure of an atom. You also need to have a basic idea of how the electrons are distributed, right? That idea that your periodic table, right, is a model of the atom structure. Okay, so that's something else that you're going to want to be careful of and keep in mind, right? When we're distributing out, and I'll explain it to you with the, Maria, I'll explain it to you with this little diagram thing. You're going to want to know how to identify neutron count, electron count, and proton count. Given a table of isotopes where I give you a bit of the information, you have to figure out the rest. And honors, you're going to want to know how to do isotope abundance calculations to figure out the average atomic mass that would go on the periodic table, and report to the proper sig figs. Okay, that's it.